Hey, good morning, guys. Good morning, guys, and welcome to Cytron's webinar series. Today is our 30th session. Today I'll be talking about the application of relay. So this session is a continuation of the previous session. In the last week's session, I talked about what is a relay. I break down the parts of a relay, show you the internal of a relay, and also explain a little bit on electromagnet. And today we are going to further explore more in depth on the application of relay, how we can use relay in different kinds of application. Okay, so like every other session, um, my style is the same. If you have questions, drop your questions in the comment section. We try to make this as interactive as possible so that I can answer your questions immediately. So bear in mind that today I'll be using Arduino Maker Uno over here, similar like what I did last week, a Maker Uno, and then I'll be using the single channel relay over here. I'll share you the link on where you can get all these components if you want to try it out yourself, and also together with all the other components that I'll be using today. And if you have attended last week's session, you will probably know that during the demonstration, there's some hiccup. The circuit wasn't working. In the end of the day, I managed to find out what's the issue, or it's actually one of the wire got disconnected internally, so it got fixed, and I updated um, the new circuitry on the circuit, right, and the whole functional a complete circuit in the our junior assemble group in Telegram. So if you want to learn more after today's session, you can always join us in our Telegram group. And yep, without wasting more time, I will do a quick recap on what we learned last week, and I will also run a quick demo on what we are supposed to do in our previous session. So today's agenda, 14. First is I will recap what is a relay and electromagnet, a brief view on what I explained last week. I won't do the breakdown. I won't show you how to build your own electromagnet, but just to quickly go through what we have covered last week. And if you are interested to see what is in a relay or how to build your own electromagnet, you can always watch the previous session. You can go to our YouTube channel and just search back the what is a relay part 1, and then just watch it. It's also an hour session. And then next I will recap the demo, which I mentioned that it failed last week. I will show you how to connect a relay to the Arduino and how to control a USB device using the relay. The USB device is not limited to just light. It's also, you can also use it for your phone charger. You can also use it for any other USB device, as long as uh, it doesn't need to have data transferred. It's just power on and off. Okay. And then I will move into our application for this week's webinar. Number one, I'll be connecting a 12-volt device using a relay. I'm not going to tell you what 12-volt device I have. I have two devices over here, and it's going to be interesting. And also, if you have been learning Arduino for some time now, you'll probably be using just whatever that is on your Arduino. over here I have a Maker Uno. So Maker Uno or any Arduino, you will have 5 volt, you will have 3.3 volt, and then that's about it. You can, so you feel like you are actually limited to just 5 volt and 3.3 volt, and you are not allowed to buy components that support higher voltages, 12 volt, 20 volt, or above. So that's not the case actually. With a relay, you can actually use components with higher voltage rating, 12 volts or even higher. I'm gonna show you how you can do that. And again, we are going to use Arduino to control these 12 volt devices, 24 volt devices, other voltage devices. Okay, so I don't want you to feel limited by the Arduino, like, oh, I have 3.3 volt and 5 volt. I can only buy 3.3 volt sensor, 5 volt sensor. Actually, that's not the case. Once you get to know a relay, how you use a relay, you actually open up a new possibilities of sensors and devices that you can control many different higher voltage devices. Okay, on the second demo, I will control these 12 volt devices that I will show you later using a relay and a sensor. Good morning, Riro. Riro is here. I think it's Cheryl. Good morning, Cheryl. And then, yeah, I will use a sensor, means that I won't program it to turn on and off my 12 volt devices. I will use an IR sensor in this case, a very simple digital IR sensor to control the relay. Okay, here's a comment from Shaman. I think that's a noteworthy mention comment. So Shaman used a 240 volt and almost shocked himself. So this one I didn't really mention it, but if you look at the relay closely, or if you have a relay at home, it actually rated 10 amp 250 volt AC. A relay works for AC actually. It's meant for AC too, but it also works for DC. Okay, 10 amp 30 volt DC. So in all this webinar session, I will only cover the DC part. The AC part is very risky and it's very dangerous. It's not safe. If you know what you're doing, then by all means go ahead. But if you're not sure, I suggest you stay at the DC side until you are very confident on connecting with AC. So AC, like Shaman said, you can get shocked. It's very dangerous. It's very risky. So I wouldn't teach it here. But again, if you have questions, I recommend you to join our Telegram group. I will share the Telegram group by the end of this session. So let's begin by what is a relay. I covered this last week, and I'm gonna quickly cover it again today. A relay is, there are many types of relay. Electrical switches that open and close circuits electronically. So this is basically a switch. Last week I showed you a normal switch, a rocker switch where you just use a finger to flip it on and off. This switch, you don't need to use a finger and switch it on and off. It's powered electronically, means you use a signal from your Arduino to turn it on and off internally. And inside this relay, the switch is actually an electromagnet, which is the second point. The switch in the relay is activated with an electromagnet. So if there's a signal passing through this relay, it will become a magnet, a temporary magnet. And then when it becomes a magnet, it will flip and touch the other metal plate. Then it will form a closed circuit, or it's like pressing the switch up. So it's once it becomes a magnet, it touches the plate, becomes a switch. So this is the symbol of a normal switch, and then this is the symbol of a relay. They are both switches. All right, one is you have to manually use a finger to turn on and off, and another is you use electromagnet, so that when it activates the magnet, it flips the switch down to the metal plate, and if you deactivate the magnet, then it goes back to its original state. So this is the difference between a normal switch and a relay. Now you just need to know fundamental, but if you want to see what's inside, the previous video, okay? Next part, what is an electromagnet? An electromagnet is what I basically mentioned just now, a type of magnet with the electromagnetic field enough to produce by the electric current. So it's basically I'm just gonna go ahead and show you some images which we tried last week. It's a coil of wire, a coiling using copper wire on a piece of rod or a core, and when you apply current through this copper, it will actually create an electromagnetic field around this copper wire, which gives this iron nail, in this case, temporary magnetic function. It becomes a temporary magnet. So this is called an electromagnet. You apply current through the coil, and then by current passing through this coil over and over again, you are actually creating a magnetic field which attracts any other metal parts. So you are creating an electromagnet, a temporary magnet. So this is what's in the relay. Hi, good morning, Chua. So this is a magnet. This is an electromagnet inside. When you apply current through this rod inside here, it's going to become a permanent, a temporary magnet, and then it's going to flip the switch. And when you take away the signal, it's gonna go back to a normal state, which it doesn't trigger the switch. Okay, so last week I talked about the relay, but I didn't really focus on how you activate this relay. Okay, this is a closer look. How do you activate this relay? This relay that I'm holding is actually an active low relay. It means that you have to program a low signal to activate the switch. And to program a high signal means you apply 5 volt to the input. Okay, that's in ground and voltage, VCC, in ground voltage. So if you apply some voltage, a signal to in, it's going to disconnect the switch. Okay, apply signal, it will disconnect the switch. You don't apply signal, it will stay connected for your switch. So this is an active low, an active low, is it active low, active high? Active low relay. So there are multiple types of relay. There are many types of relay. It just so happened that I have this type of relay here. Okay, let's see. Question here from Chua. Electromagnet can make what product? This is the one of the product I'm talking about, a relay. So in a relay, you are using this electromagnet in here as a switch. So you are basically applying signal to turn on a switch, and you normally have switch and then you use your finger to control it, right? On and off, on and off. But in this case, you don't want to use a finger to on and off. So you apply a signal, a current, and then it creates a temporary magnet inside to turn on and off a switch. When it becomes a magnet, it attracts to the other piece of metal plate, and then it creates a switch. And then when you disconnect the current, then it will go back to its normal state. So in this case, later on, I will show you how to use an Arduino, send a small signal to a relay so that it can turn on and off this switch to power on and off a different device. All right, cool. Other applications of electromagnets, for example, okay, I'm just gonna go ahead and break it to you. I will be using this 12 volt device. This is a door magnet, a door lock. Okay, when you go into some office, you will see that, okay, there's a door magnet at the top. Let me go ahead and show you a bigger screen. Okay, I'll be using this later. So this is a magnetic door lock, but right now it's not magnet. So actually this thing is using electromagnet as well. I have to apply some current in here so that it becomes a magnet. So right now it's not a magnet there, you see, it doesn't stick. So later on when I apply 12 volt here, this will become a magnet, and then this will stay on, it will start here. So this is electromagnet, one of the applications of electromagnet. But I'm not here to talk about this. Later on I will use a relay to control this electromagnet, and then we can use our sensor to control this door lock. So I hope I answered your question, Chua. If you have more questions, please ask, and I'm very happy to answer your question. So first demo, this is a recap demo for our previous session, which I said there's a hiccup, a minor hiccup. So I'll be switching on and off a USB device with a relay. This is the device that I'm going to switch on and off. I'm pretty sure you have seen this before. It's an LED with a USB at the end, an LED stick where you can just bend and then things like that. So normally we connect this on a USB port to our laptop, to our adapter. But today I don't want to connect it to my laptop or to my adapter. I want it to be able to program this. I want to program this to turn on and off. I want it to turn on for 5 seconds, turn off for 3 seconds, things like that. So how do I program this? So that is where an Arduino comes in. So in this schematic here, a very simple schematic, my Maker Uno is going to control a relay, and then my relay is going to turn on and off this USB device. Okay, you can see I power my relay, and then my relay is going to control my USB device whether it receives power or it doesn't receive power. A more specific schematic will look like this. My Arduino connect to the relay. In order to use a relay, first you will need to power it up. My relay is the VCC, the operating voltage is 5 volt. So I have to power up 5 volt and ground over here. And then I have to connect it to a digital pin, which is D7 to the in. Okay, there are 3 pins here. Once I do that, when I program my Arduino to turn on digital right high at pin 7, it will control on and off of this relay here. Okay, let's see. Another question from Chua. Arduino use what language? Arduino is basically C, but it's a much more user-friendly C where it's easier to understand as compared to the original C. And so it's a language itself. It's based on C, but it's a very intuitive, easy for students to understand. The words that they use are not very complex, not like C++. You can really read it, you can really understand it. But Python, of course, is easier than this. Okay, so we are gonna program this simple program on the right side here. The test code is right here. It's a very simple piece of program. I'm just gonna program my pin 7 to turn on, off, on, off. But in this case, the delay is 5,000. So I'm gonna change the delay a bit so we can see the difference. Let's move on to the hardware side. I have a couple of hardware that I have to show you. Okay, let me change my screen. Okay, here are some hardware. I hope you can still hear me. Here are some hardware that I'll be using, including the relay here. I have my Maker Uno, and then my power adapter. These are for the next demo. Okay, but later on I'll be using some of these stuff. I'm gonna put it at the side first. To use a relay, you will need a screwdriver. Okay, you need a screwdriver to remove this part and to connect your wires on this side. There are 3 holes here. Okay, the center one is the voltage that you have to put in. So basically, 2 of the holes are like a switch between whether it's connected or disconnected. So you have to connect one side of this. In this case, I will connect to this normally closed pin. And then on the other side of the relay, actually this is a relay module, right? A module means that it's already pre-soldered and with all the components needed on it. It's easier to use too. You can just plug your wires in and then you can directly use this module. If you buy a relay without a module, it's gonna be just this blue color piece, which I showed last week. And you have to solder it yourself. It's very messy. You have to include other different components yourself. All right, next. So over here we have 3 pins on the other end. These 3 pins, I'm gonna read it out. The bottom one is VCC, the center is GND, the ground, and then the top is in. Following my circuit just now, I'm going to go ahead and connect these 3 wires using a female to male wire. Okay, bear in mind that I've checked all these connections already to make sure I don't make the same mistake as last week. Last week, one of the wires is disconnected internally. So first, I'm going to connect the in like that. Hi Sam, thanks for joining in. Thanks for tuning in. If you have questions, you can drop your questions in the comment section. I'll be looking at it on and off. So connect the 3 wires to the 3 pins on the other side of the relay, like that. The ground and the VCC is to power up the whole module with the relay, and in the orange wire is to control the relay whether it's supposed to be on on state or off state, depending on the program, high or low. So VCC, I'm going to go ahead and connect it to 5 volt. Okay, 5 volt on the left. And then the ground, center pin to the ground. So these will power up my relay, ground and 5 volt. Okay, ground and 5 volt. And the orange wire, the int, I will connect it to pin number 7, which is the program that I will be programming later. Hi Sam. Okay, I believe you're asking what am I doing here. So today's session is about relay. I will be turning on and off. I will be controlling this USB device. Okay. Unfortunately, today's session is in English, so but I understand what you're asking. I'm gonna use this Arduino to control this USB device. Okay, USB device. So what else I need? I will need to connect my USB device to USB ports, of course. So I will need this. So these are already pre-soldered, a male USB port and a female USB port. This will allow me to pass the voltage to my USB device through the relay. So next, I have to connect my relay on this side. So what do I need to do? First, I will release the terminal. And then next, I will pass the voltage. Let me just uncoil the wire. So I'll be bringing 5 volt to this guy. Okay, I will pump 5 volt here. But first, I have to connect it here, this way. So this is the positive voltage. Okay. Sometimes the wire is too long. If it's too long, then always prepare to cut it short. You don't want your wire to be excessive, until it comes out and then the wire will accidentally touch the side of the terminal. You don't want that. You want it to be fully in, fully locked down, like that. Okay, it stays. Number 2, I'm going to connect it here with my another end, my female USB port. Okay, if you can't follow you don't know what I'm doing right now, later I will show you the schematic again so you have a better picture, and I'll explain it from that point of view. And I'm gonna move down a bit so you get lesser of this distraction. Okay, I'm gonna take one of these and I am going to connect my grounds together. This terminal is good because you don't need to screw, you just need to press and then connect your ground together. So this is how my circuit looks like. This USB is going to get me voltage to this part, the end, and this end is to connect it to my LED. Okay, LED. So by default, I can connect this USB directly to this part. Okay, let me quickly show you since you're here. If I connect it this way, okay, this is a very straightforward positive of this part to the positive of this LED, negative to the negative of this LED. And if I power it over here, I have my USB port here. If I power it, okay, it's going to turn on. See, the light will turn on. So this is very straightforward, but I can't really control on and off. I can't really program. I want to program this thing. So now it's on, and then I turn off the switch, and it's off. I want to program it now. So how do I do it? Using a relay. This is where a relay comes in. So back to the relay, plug it in, screw it in. If you want to let students try using relay, I suggest try something simple like turning on and off an LED, so that they understand the concept of a relay before you introduce them plugs of 5 volt but of course DC is still safer than using AC. So now I have my positive connected here, and then my positive between this is connected to the relay. I am going to power up my Maker Uno right now. Take a cable, plug in, and then plug to your laptop. Okay, I'm going to switch my screen to show you what program I'm going to use. Sorry, there's a program in there. So this is the schematic that I'm trying to connect just now. Switching my screen back. This circuit is what I've already connected right now. Now I have to upload the program next to it. Okay, you can see the program there. So I have my Arduino IDE over here. A new Arduino IDE. Make sure that you are selected to Arduino Uno, and then your port are selected, and then go ahead and program it. Quickly program it. I connected my I connected my relay into the Arduino pin 7, so I have to program pin 7 as an output. So it will send a signal to the relay to turn it on and off. And then I will control. So I'm not using any variable right now, just to make things simple. I'm going to turn on high for 5 seconds, and then I'm going to turn my 7 low for 2 seconds. With this difference, instead of using 5 seconds and 5 seconds, I am going to make it different. 5 seconds, 2 seconds, so I can tell when it's high, is it on or off, and when it's low, is it on or off, so that we know this relay is active high or active low. Okay, upload the code. Go ahead, upload the code. Uploading it to my Maker Uno right now. Again, this is a very simple piece of code. Digital write high means you send a signal through your pin 7 in this case. Delay is delay for 5000 is 5000 millisecond, which is 5 seconds. And then 7 low is to send a 0 signal. All right, so let's move to the screen here. So now I've already uploaded the code here. You can see this is my plug. I turn on my power already. 5 volt going in. So now my LED turns on for 5 seconds and turn off for 2 seconds. On 5 seconds, off 2 seconds. In this case, when I send a high signal, my high signal will turn on for 5 seconds. This means that it's active high. Turn on for 5 seconds, turn off for 2 seconds. On for 5 seconds, off for 2 seconds. So now I've created a very simple application here using USB to control a USB device. Okay, this is actually a last week's application. So I have to move on right now to our next application. And the next application that I would like to try is, instead of using a USB device, right now I want to activate and deactivate this magnetic door. Okay, in the slide here, you can see that I am going to use a 12 volt power instead of a 5 volt right now. And then I'm going to connect a 12 volt device. Everything on the Arduino side is still the same. 5 volt to relay, ground to relay, 7 to relay. And then the code is still the same. Okay. So here, this is my magnetic door lock. Okay, this is the that piece on the top. Okay, now it's not connected, you see, there's no magnet. So disconnect everything, power off, remove your USB cable from your Arduino. For safety, remove all your wires first before you proceed. Next, I want to connect my power supply. So I have to remove all of this because I'm not using this anymore. Remove this. And then, yeah, take this away. Take this away. Okay. So now let's connect this on one side. I have my 12 volt adapter, 12 volt to amp. Again, the adapter depends on what devices you're going to use. If you are going to use a 24 volt device, then don't use a 12 volt adapter. It's not going to work. And of course, the current matters too. If your devices need more than 2 amp current, then you have to, make sure that the current of the adapter is able to support it. So here, I'm just going to connect it, but don't turn on yet. And then on the other end, okay, this side, there are 3 ways to do this. Number 1, you go ahead and cut this and then expose the positive and negative wire. Okay, that's very, you can't reverse, irreversible process. So once you cut it, that's it. But I would recommend you to get things like this. When you connect this, you're actually exposing the positive and negative, which is very useful. And that's another way to do it, which is this. When you connect this, you have your positive and negative here. You just need to connect a wire on the other end, positive and negative. Then you have access to your 12 volt here. So in this case, I don't want to connect another wire anymore. I'm just going to use this positive and negative. With my 12 volt, I'm going to connect my 12 volt positive to the center of the relay here. So release the screw, connect the 12 volt in. Okay, make sure it's not too long so that it doesn't expose. Push it in, lock it down. Number 2, I want to connect my other positive end of my device to the other side here. Meaning, the switch is here, right? So it's in charge, turn it on or off between the positive side. But of course, the wire right now is very short. You can always extend it longer. And then at the end, I have my both ground, negative, negative, negative. So just use a block terminal, put them together like that. So there you have it. It's a very simple setup. And then haven't turned it on yet, but you can see, okay, it's not connected yet. So what I need to do next is power up my Maker Uno and then turn on my 12 volt. My program is already in my Arduino, so I just need to connect a 5 volt straight to my Arduino. Straight to the Arduino here. Alright, all this distraction away. Okay. So turning on my Arduino, and then once my Arduino is on, okay, still not yet because my 12 volt is still not on yet, and then turn on my power switch. So now you can see it's on, and then oops, sorry. So it's on for 5 seconds and then disconnect for 2 seconds. This is what the relay is doing right now. On for 5 seconds, disconnect for 2 seconds. On for 5 seconds, see? And then disconnect for 2 seconds. Okay. Alright, a better view of the entire circuit here. But again, the schematic I already shared to you, so you can always follow the schematic. So now basically what is happening here is that you are using your Arduino that doesn't have 12 volt on top here, but you are still controlling a 12 volt devices here by using an external power of 12 volt. The 5 volt is for your Maker Uno. I'm not connected to my laptop right now. My Maker Uno is programmed to turn on for 5 seconds and off for 2 seconds. So it will turn on for 5 seconds, on for 5 seconds, and then off for 2 seconds. For 2 seconds. Cool. Any questions so far? Any questions? Okay, if no questions, moving on to the next part of the demo. So demo part 2, you are still switching on and off a 12 volt devices using a relay, but I'm going to add an infrared sensor. So imagine you walk in front of your door and then your magnetic lock just automatically turn on or open up the door. So you need to use a sensor to automate things. If you program it like this way, in this case, I fix my time 5 seconds on, 2 seconds off, then it's just a demonstration. But for a real application, you need to have sensors, or you need to do more than just hard coding it. Okay, take a look at this schematic right now. Again, I will share these slides at the end of the session in our Telegram group. If you want the slides, join our Telegram group. I will share it there. I have my 12 volt power device, the power adapter connected to my 12 volt devices. My relay is still connected to my Arduino. Everything is the same except for the IR sensor. I have to add this extra IR sensor to my Arduino. So IR sensor, I have 3 wires here: voltage, VCC, ground, and a digital pin. This is a digital output sensor. Okay, switching my screen back to my here. I'm gonna turn off everything. Again, when you want to connect anything, turn off all your power. For safety, to prevent shortage, you never know what will happen when the things is power on and then you are trying to connect a circuit. So this is not okay. There's no power anymore. All right, I'm moving here. So my IR sensor. If you learn about robotics or all this IR sensor may look familiar with you. Okay, there's a receiver and then there's a transmitter. The signal will go up, and then when it reaches a certain object or a white object, and then it will bounce off the signal back to the receiver. Transmit, receive. This right now it's not an analog signal, it's a digital signal, so it can tell you whether there's an object in front or there's no object in front. That's it. It doesn't tell you, it can't measure distance. For this case, it's not analog. And then connected to 3 male to female wires over here, male to female. And then now I connect it to my Arduino. So for the ground, okay, let's move this to the side so that you have a better view. Disconnect this. For my voltage VCC, gray color wire, I'm going to connect it to 3.3 volt. This sensor works for 3.3/5 volt. So I'm going to connect it 3.3 volt since there's a 3.3 volt here. And then white color, connect it to ground. So ground over here. Last wire, digital pin to receive signal from my IR sensor. So I can connect it to any pins, but in this case, I'm going to connect it to number 9. So there you have it, it's done. Just like that, very simple. Now I can program my IR sensor to control my magnetic lock on and off. So I have to connect my Maker Uno to my laptop right now so that I can program it. Okay, and then connect it to my laptop. So this is the schematic again. I didn't show you the test code this time. We are going to type it together. But when the Maker Uno is powered on, the relay is also on. And the IR sensor is also activated, it's also on. So everything is on right now, but you have to make sure that the circuit is connected correctly first. So back to my previous program. Okay, now I'm going to create a new one so you can see from fresh how to program a sensor with a relay. So first things first, I'm going to leave this here. You will need to know what is being connected on top of your Arduino right now. So first, pin mode. Pin 7, earlier on, pin 7 was connected to my relay. So I will just go ahead and use pin 7. Okay, as an output to control the relay. And then I have my new one, 9, pin 9, IR sensor receiving. So when it's receiving, it's not giving out, it's receiving its input. So this is the only two I need. And then next, I want to control my relay based on the IR sensor. So I need to read the signal of my IR sensor first. And I'm going to give a very quick one-line syntax for reading signals from the pin 9 in this case. So pin 9 IR that underscore sensor. This is a variable. Equal digital read pin 9. So this will read pin number 9, whether it's high or it's low, what's the signal in there. And then next case, if my IR sensor is receiving 0, then what should happen? It should send a signal to my relay. Okay, I'm going to make some comment here so you understand. This is for relay, and this is for IR sensor. So digital write 7. Okay, I'm going to disconnect because the relay is very noisy. Digital write 7 is going to go low when it's 0. And then it's going to delay for a period of time so that you have time to open the door. If you don't delay, it's going to be open close, so you don't have time to really open the door. If you go to your office or any other place, when you scan your card, it opens the door and then it remains open for a period of time, maybe 5 seconds, 10 seconds, then it locks again. So you need a delay for that. If you don't delay, then it will just open and close and then lock the door back again. So by doing this, I actually I have to go high to turn on, and then it locks, and then after that it turns. When it turns on, it goes, yeah, and then it deactivates the relay. All right, so this is the code that I'm going to use right now. There's no tone, there's no nothing. It's just on and off based on the IR sensor signal. Go ahead, connect your Maker Uno and select the COM port. Upload the code. Okay, so once it's uploaded, let's switch our screen. Okay, hold on here. Switching screen to this. Okay, I believe my high and lows are reversed. So what happens here is, okay, my IR sensor is over here. Right now I program it by default, my door is open. And when I put my hand in front of the IR sensor, it's connected. And then when I remove my hand, for 1 second later, it disconnects. So again, it works. My IR sensor is working well. And then my relay is still functioning like previous. By default, it's not connected. And then once I put my hand here, it's connected. And then remove, it's disconnected again. Okay. Connect. Disconnect. Okay. So there you have it. IR sensor controlling your magnetic door. So now adding more stuff to my code. I want to have some beep sound on my system, like every other door in the real world. So just easily I add, because Maker Uno have a built-in buzzer, so I can just simply add a buzzer to this whole system here. This I'm gonna change the low, and this I'm gonna change the high, and then if it turns on, it activates the magnetic door, and this one is gonna deactivate. Here I'm gonna add a tone pin 8 to let's see, 500, and then here no tone 8, and then upload. Okay, Shama, I have a question here. Let's see. It works for the same with Arduino Nano, right? Yes, correct. It works for the same with Arduino Nano. Actually, it works for anything, any other Arduino, as long as the signal that you come out is what the relay is looking for. In this case, my relay works with 5-volt signal, and you need to power up your relay 5-volt and ground, and Nano has it. So it works for most of the Arduinos that you can find. The thing is, the circuit that I've connected on my relay doesn't change since the first demo until the third demo right now. Everything that is working right now, it depends on the external voltage that I'm using, the 12-volt for the the magnetic door lock. Okay. Yeah, I'm uploading this new code right now. Okay, it's taking some time. Go again. Compile. Upload. Okay. Disconnect. Connect. Upload. Okay, sometimes you get error. Sometimes the connection wasn't well, so you get error. So I just disconnect and connect my USB and then done uploading. Moving back to this. So now I have my new code in here. By default, okay, I'm gonna turn on my 12 volt. By default, this is going, my door is closed by default, and then when a person walks past my RF sensor, this disconnects. Okay. I actually programmed my buzzer to turn on, so Maker Uno has a built-in buzzer. So when a person walks past, you can hear my buzzer turns on, and then this also turns on. A person walks past, turn on, and then, but of course my delay is only 1 second, so there's no time, not enough time for me to open the doors. Walk past and then open. Okay. All right, so this is the last of the demo here for this magnetic lock. So if you want to change it to a different other components, what should you do? It's very simple. The connection are always the same. Again, if you look at the photo here, I didn't really tell you what are the 12 volt devices that I'm referring to, because it's not limited to any devices as long as it works with 12 volt. It depends on the power that you are putting in. Okay, right now 12 volt power, but you can put 22, 24 volts. But the limit is for 30 volt lah, for this relay in this case. So if you put 24 volt, you can use 24 volt device. If you put 12 volt, you can use 12 volt device. So here I have a very dirty water pump. I'm gonna show you here. Okay, I have a water pump here. I'm not gonna use water around here, but I'm going to connect this water pump to replace that magnetic lock. It's also 12 volt power. So just turn off everything, and then disconnect my magnetic lock here. My magnetic lock is actually just 2 wires away. Only 2 wires, only 2 wires. Leave it one side and then bring my 12 volt pump and connect it here. As long as the polarity is correct, it will work. 12 volt and then the side ground. Same connection, different device. Okay, move this on this side and then power everything on. Power on, power on. Right, so right now, is my pump working? Okay, let me turn off my buzzer. Okay, check, make sure the connection is okay. Oh, I need to turn on my pump. Okay, last I checked, the pump is working, but again, the connection is the same. No water to demonstrate. The pump should turn on and then turn off when my hand goes in front of the IR sensor. But this is the connection here. 12 volt, enter that to the pump. My polarity is correct. Yeah, my pump is on right now. I don't know if you can hear it, but the pump is on. It's a very, it's on, and then hand to the front of the IR sensor, then it turns off, and then it's on again. You can only hear vibration because there's no water to demonstrate. But yeah, that's all, folks. How you can connect a 12 volt device to a relay and your Maker Uno and the sensor. Okay, let's see. All right, guys, I encourage you to ask more questions. We have 5 more minutes, and while we are at it, I'm going to wrap this up for this session. Here are a list of hardware that I use for today's session, but of course, I will be sharing these slides later on in the Telegram group. So join us in our Telegram group. I will share with the Telegram group later. A few things that I would like to share with you guys. There will be a crazy sales from Cytron on the 30th November. It's 2 weeks from now, and you're invited to browse through Cytron's website. We have a 24 hours sale, 12 a.m. to 11:59 p.m. on a single day. It's all on a single day. We have crazy discounts. By default, everything on store is 30% off, and then you can get vouchers 20% to stack on a 30% to get 50% off. So yeah, that's why it's called crazy sales. So join us on our 24-hour sales on 30th November. You can check out our website. The website link is down below right now in this live session. It's always been playing, www.cytron.io. So go check it out. And then next thing I would like to promote, this is from our partner. They are running a Penang International Science Fair 2021. So Penang International Science Fair is a very popular science fair event, physical event that is happening throughout many years. Okay, this year they will be running their first virtual Penang International Science Fair, and it's gonna happen today, 20th November, 2 o'clock. So go to their website or go to their Facebook to watch their opening ceremony today. And if you go to the bisfbscbn.com, you'll be able to browse through their events. They have virtual booth, they have workshops, they have competitions, talks, and many more stuff. So go and check it out, and I'm sure you will learn something from there. Next, Telegram group. If you want the slides, if you have other questions that you would like to ask, join us in our Telegram group. I think most of you guys are already there, but if you are not there, do join us. Share this link with your students, share it with your friends. You can scan the QR code, or you can use this link over here. Wait now. So this is the Telegram group. You can use Telegram desktop. You can use phone app. The whole Telegram group is meant for students to ask questions. If they have Arduino problems, if they have coding problems, electronic problems, they can ask. There are engineers in there that are able to help. And then next. I know you are here for this. So if you have any feedback for today's session, I hope you enjoyed today's session and you find the content valuable. I'll be sharing the slides again. But if you have something that you would like to share or you would expect to see in the next session, do let us know. Scan this QR code or type in the link here. I will share it in the chat right now. Okay, I just sent the Telegram link in the comment section. You should be able to see. You can click the link directly and join the Telegram group. And right now, I just shared with you the feedback form. Fill in the feedback form. Let me know what you think about today's session. If you like it, if you hate it, whatever you want to see in the next session. Fill in the correct email and you'll be able to receive an e-certificate quite immediate, and then the link will be closed by 1 o'clock today. Okay, let me share again. I think it's already shared. So yeah, I again thank you for tuning in today's session. The timing is just right for today. And again, if you have questions, I will see you in our Telegram group. All right. So thank you very much for tuning in. And I will see you again next week. Next week, just a hint, we will be talking about Zoombit, one of our new robotic, microbit robotic kit. We will be demonstrating to you how to use a Zoombit, what's in a Zoombit. We will do an unboxing to show you what's in there. So stay tuned for our next Saturdays, 11 to 12 o'clock, Cytron's webinar series. Thank you very much, and I'll see you again.